We're going to talk about tides and tide cycles today. So we're looking at what causes tide cycles on Earth. So if I'm looking at the picture on the screen, I can see these like sort of changing images of high tide and low tide. And you can see how people can walk on the shore or the beach during a low tide, but they sure can't do that during high tide. So tides are a cycle where seawater rises and falls according to the positions of the Earth, the Moon, and the Sun, which is the three objects we've been talking about for, a couple weeks now. A tide cycle lasts 24 hours and 15 minutes, so slightly longer than a day. So in other words, as the Earth is spinning, rotating on its axis, there are times when it's closer to and then turning away from the moon. Well, when you're closer to the moon, and then by default, the opposite position of that, you have high tides. When you're turning away from the moon, you have low tides. Tides are the daily rise and fall of Earth's waters on its coastlines. Most coastal locations on Earth experience diurnal tides, which means you get 2 high tides and 2 low tides every day. As the tide comes in, the level of water on the shore rises, and as the tide goes out, the level of the water goes down. And this happens very incrementally, like every 6.5 hours, you see the rising of the water, the falling of the water. So what causes tides? Well, gravity causes tides. It's the gravitational pull of the moon and the sun. But we have to remember that while the sun is super massive, it's really, really far. And while the moon is much smaller than the Earth, it's really close. So its relationship to the Earth is a more dynamic. It matters more in this case than the sun's gravitational pull. So what factors affect gravity? Well, gravity is affected by mass and distance. So again, huge sun, super far, little moon, super close. It's the distance in this case that's actually more important to the gravitational pull. Why is the moon more important? Because it's closer, right? It's closer. It influences the tides every single day. The sun comes in and starts to influence twice a month where it super matters. But on a day-by-day basis, it's the moon that makes the difference. All right. So the moon's gravity pulls most strongly on the side of the Earth nearest to it, which makes sense. So if this is the moon and the moon's going around us really slow, takes a month to do that, and we're turning every 24 hours, then whatever side of the Earth is nearest to the moon has a high tide. You can see the water kind of bulging out here. And then as you're turning away from the moon, you experience a low tide. Now you'll notice there's 2 low tides happening at the same time and 2 high tides happening at the same time. And this is where physics comes in, right? So it creates a tidal bulge of water, and that's high tide here and then opposite here. This also creates a high tide on the opposite side of the Earth. So the gravity is pulling on the Earth moves slightly, but its water moves more. It's kind of hard to think this way, but the Earth itself, when the moon's gravity is pulling on it, it moves too. So when it moves towards the moon, the water moves towards the moon because water's fluid. It's going to just grab onto that and respond to that gravitational pull. But the Earth itself moves too. So what happens to the water on the other side? I mean, think of it that way. If the water on this side is being pulled and the Earth's being dragged with it, the water on the other side is falling behind. It's dragging too. It looks kind of like 2 high tides. The sun is so large that its gravity also affects tides. At times, the sun and the moon pull together on Earth's waters in the same direction. And at other times, they pull in different directions. So the sun is only really important during a new moon and a full moon phase, because at that time, we've learned that the moon, the sun, and the Earth are all in straight lines. So it's like the moon and the sun are working together to extra pull on the Earth's waters. And then when they're not together, like at first quarter and third quarter, now they're working against each other and it diminishes the tidal effect. High tides occur on most parts of the earth twice a day when your location on earth is closest and farthest from the moon. So in this diagram, that would be positions A and position C. And we can see here just that example of high tide. Low tides occur on most parts of the earth twice a day as well when your location is between the high tides. So in other words, you'd be at locations B and D. And again, that visual depiction of how extreme your high and your low tides can be. So in a 24 and a half-ish hour cycle, you should see a low tide, a high tide, a low tide, a high tide, and it's a continuous cycle from there on out. As the earth is moving, it's spinning, sometimes closer to the sometimes closer to the moon, sometimes farther away, you get that high and low tide effect. And you can see that in this animation here. So there are two kinds of tides that are sort of special. They don't happen every day like high tides and low tides do. They're called spring and neap tides. And this is where the sun really matters in this sort of relationship. So when the sun, the earth, and the moon are in a direct line, 180 degrees, straight line.
Good morning, Mustang. Please pardon this interruption. Teachers.
So this happens twice a month during a full moon and a new moon because those are the alignments, right? In a new moon, it's sun, moon, because the moon is always nearest to the sun, sun, moon, earth. During a full moon, it's sun, earth, moon. So these are straight lines. And what happens here is that you get the highest high tides and the lowest low tides during that entire month. So this is going to happen twice. It correlates with the new moon phase and the full moon phase. So you're going to get the greatest difference between high and low tides because the sun and the moon are working together. They're really, really pulling the waters for the high tides. And if you're really pulling the waters for the high tides, then it means the water that's left in the locations where it's low tide is lower. So you get highest high tides, lowest low tides, greatest difference, greatest tidal range during a spring tide. So twice a month this occurs. So combined gravitational pull, twice a month, the sun and the moon work together. And think of a spring, like they spring out, like the high tides are super, super, super high. Neap tides are when the sun, the earth, and the moon are at a right angle, 90-degree angles from each other. So you can look in a diagram here, you can see that 90-degree angle. And this occurs also twice a month because it's happening during the first and third quarter moon phase. The sun and the moon cancel each other out, causing there to be the least difference between high and low tides. So now they're working against each other. So you're seeing the lowest low tides, you're seeing the least difference in tidal range. So your high tide's not so high, your low tide's not so low. And if it helps you to think of like a 90-degree angle and a neap tide, it's kind of like your knee, right? Your knee is a hinge joint, and that's a 90-degree angle. And we can kind of see that cycle play out here. New moon, first quarter, full moon, last quarter. Those are our four main moon phases in order. And you can see a big difference on May 5th during that new moon and a smaller difference between high and low tide on that quarter moon that's following it.